Okay, this is week 4, recent advances in transmission insulators. I'm your teaching assistant Ninda Khanam, research scholar from Department of Electrical Engineering, Aligarh Muslim University. So today we will discuss about cleaning, coating methods, introduction to hybrid insulators. Okay, in previous session we have discussed different types of insulators, their manufacturing process, design, criteria, field experiences, and many more things. Okay, today we will discuss upon cleaning methods which are used for transmission insulators. So basically, insulators in power transmission and distribution systems play a crucial role in preventing leakage currents and ensuring system reliability. So over time, they accumulate dust, moisture, pollution, and other contaminants which can lead to flashovers and insulation failures. So cleaning insulators is very important to maintain their performance and extend their lifespan. So the main scope of insulator cleaning includes power transmission and distribution systems like overhead lines, substations, and switchgears. And also in industrial environments, the area which is exposed by the chemical pollutants, oil residues, and industrial dust. And in coastal and desert regions, as we know that insulators exposed to salt contamination, sand, and high humidity. So, and in railway and metro networks, high voltage insulators used in electric traction systems, they also need to do cleaning methods. Okay, so why we are applying cleaning methods? Because cleaning insulators have several multiple objectives. If we want to prevent the flashovers, like due to flashovers, there will be a surface leakage currents inside the conductors and conductor insulators becomes conductor due to flashovers. So by cleaning, it reduces the surface leakage currents which are caused by the contamination. Second is enhancing reliability. By cleaning procedure, it ensures the stable power transmission and distributions, and it also reduces wear and tear, improving insulation durability, and it minimizes the maintenance cost and prevents the frequent failures and costly repairs. Okay, and finally, the main measure is ensuring safety. It prevents power outages and hazards due to the insulator failures. By applying proper cleaning methods to several insulators, we can achieve these multiple objectives. Okay, as we know the ceramic insulators can be cleaned in a number of ways, and they can either be energized or de-energized. That means the most common methods which are used for cleaning the ceramic insulators are high pressure water, in which water is at the pressure of 2750 kilopascal to 7000 kilopascal are applied to clean the insulators. Second is medium pressure water, in which the pressure rate is 2100 kilopascal to 2750 kilopascal. And at low pressure water, flood wash, at which the rate of pressure is 1400 kilopascal. And low pressure water fixed spray nozzle we can also use. And compressed air cleaning, where CO2 pellets are absorbed by the insulator surface. And hot wiping can be used for these are used for live line tool. And lastly is the manual cleaning, that is why the insulators are can be cleaned by manually by wiping or cleaning the dust. Okay, these are the methods which are commonly used for cleaning the ceramic insulators. So in polymer insulators, manufacturers to be consulted prior to cleaning for advice on their respective products and applicability of cleaning methods. So there are some cleaning methods, techniques which are used by the several insulators like porcelain, glass, and composite insulators. So the choice of cleaning technique depends on the insulator types, contamination level, and operational conditions. Like the four different methods which are being used for cleaning the polymer, porcelain, glass, and composite insulators are dry cleaning methods, wet cleaning methods, live line cleaning methods, and special cleaning methods. So Moving on to the next cleaning method. Internet connection issue actually. Okay, we are discussing cleaning techniques for insulators. So basically, insulators comes in various materials designs, including porcelain, glass, and composite insulators. And the choice of cleaning techniques depends on the insulator types, contamination level, and operational conditions. So there are several different techniques for cleaning the insulators. Like we are having dry cleaning methods, wet cleaning methods, live line cleaning methods, and special cleaning methods. So in dry cleaning methods, so first is brushing and wiping. So as you can see the figure, the insulators are cleaned by the large pressure water, and the methods used for removing loose dust and dry contaminants, and we use the soft fiber brushes, cloths, or sponges are used to wipe the insulator surface, and ideal for low and medium voltage insulators they can be used. And the main advantage of using this method is because it is very simple and cost effective, and is it does not require de-energization of the systems, but it is very ineffective for heavy contamination, and it cannot remove sticky deposits such as oil, salt, or industrial chemicals. So next method is compressed air blowing dry cleaning method. So in this we provide the high pressure air is to blow away dust and light pollutants, and it is often used in dry and desert regions where use is impractical. It is a non-contact method and it reduces the risk of damage, but it is suitable for areas where limited water availability. But it cannot remove stubborn or sticky contaminants, and it requires the specialized air compressor for cleaning. Now, next cleaning method is wet cleaning methods, in which high pressure water jet cleaning, as you can see in the figure, is used, and a high pressure jet of deionized or distilled water is sprayed on the insulators to remove contaminants, and it is commonly used in substations and high voltage lines. So, main advantage of using this method is that it is very effective for removing salt, industrial pollutants, and bird droppings, and no mechanical contact, reducing wear and tear on insulators, and it requires a specialized high pressure water systems, and water quality must be controlled to prevent the conductivity issues. Okay, next method is steam cleaning. In this method, steam is directed at the insulators to dissolve the contaminants, and it is used for heavily polluted insulators in industrial and coastal environments. The main advantage of using this is it provides the deep cleaning effect and it does not leave any chemical residues. But it requires the steam generating equipments, but it may not be suitable for composite, which is also known as polymer insulators, due to heat sensitivity. Mm. Now, the next method for wet cleaning is chemical cleaning, in which especially formulated cleaning chemicals are applied to dissolve and remove pollutants such as grease, oil, and industrial residues. And after application, the insulator is wiped or rinsed with the water. It is very high. It is very effective for stubborn contaminants, and it extends insulator's life by preventing material degradation. But some chemicals that can degrade the polymer insulator, so it requires the careful handling and disposal to avoid environmental harm. Now, the next cleaning method is the live line cleaning methods, in which hot line washing is used. That is, deionized or distilled water is sprayed under controlled pressure onto energized insulators, and the water is applied from a safe distance using insulated equipment. And it allows cleaning without shutting down the power supply, and it removes the contaminants effectively and prevents the flashovers. But it requires skilled operators and social equipment and cannot be used in adverse weather conditions like where rain, thunderstorms occur. There we cannot use the hotline washing methods. Now, second is the helicopter based cleaning, in which a helicopter with the high pressure water jet system sprays water on insulators, and it is used for ultra high voltage systems lines in remote areas, as you can see in the figure. And the advantage of using this method is that it's very fast and efficient for cleaning large transmission networks, and it reduces the maintenance downtime, but it's very expensive and requires trained pilots, and it's not suitable for low voltage or urban networks. Now, fourth method is the special cleaning methods, in which the robotic cleaning is done, and in this, autonomous or remotely controlled robots equipped with brushes, water jets, or ultrasonic cleaning tools are deployed on transmission systems. Okay. In this method, autonomous or remotely controlled robots equipped with brushes, water jets, or ultrasonic cleaning tools are deployed on transmission lines, and it reduces the human risk in high voltage environments. It is very consistent cleaning with minimal manual intervention, but it requires very high initial investment and requires regular maintenance of a robotic system. Now, second is ultrasonic cleaning, and in which high frequency sound waves generate microscopic bubbles that remove contaminants, and it is used for sensitive electronic and substation insulators. The main advantage of using this type of special cleaning method is that it is non-contact method, and it reduces the risk of damage. It is very effective for precision cleaning, but it is limited scalability for large power transmission networks, and it also requires the specialized ultrasonic equipment. Now, the main selection of cleaning method which are based on environmental conditions are given in this table, in which the environmental conditions, depending upon the environmental conditions, the manufacturer recommended the cleaning methods, like in dry or dusty areas, the manufacturer recommend the cleaning method is brushing or air blowing, and in coastal regions where salt or contamination depositions, there we use the high pressure water jet hydrophobic coatings, and in industrial areas where chemical pollutions here we require the chemical cleaning, steam cleaning, and in desert environments where sand and dust deposition occurs, then the manufacturer recommended the air blowing and silicone coatings. And in high humidity regions, rain-based self-cleaning anti-pollution grease method can be used, and in high voltage live lines, we use the hot line washing, and helicopter-based cleaning can be used for cleaning purpose of the insulators. So here we done for the cleaning methods which are used for different insulators, and what are the selection criteria of depending upon the environmental conditions, what cleaning methods are recommended. Now the next topic is coatings. So before that, there are some preventive measures to reduce the cleaning frequencies. So there, as we know that the insulators in power transmission and distribution systems are exposed to environmental contaminants such as dust, salt, industrial pollution, and bird droppings. So these contaminants can reduce the insulator's performance, and leading to flashovers, power outages, and increased maintenance cost. So implementing preventive measures can significantly reduce the frequency of insulator cleanings, and it enhance the reliability and extend the lifespan of the insulation systems. So there are some preventive measures like we can use the hydrophobic coatings, anti-pollution grease, or self-cleaning designs, and regular maintenance and monitoring. These things are will be discussed in next slides. So now we discuss the coating techniques for insulators. Because why we are doing coatings? Because coating techniques play a very important role in enhancing the performance and lifespan of insulators, which are used in power transmission and distribution networks. So these coatings protect insulators from contamination, pollution induced flashovers, and degradation caused by environmental factors such as dust, salt, moisture, and industrial pollutants. So in this coating techniques for insulators, we will discuss the different types of coatings for insulators, what are the application techniques are being used, and different coatings applications, advantages and disadvantages, and what the selection criteria are being used for coating materials. Okay, so the first is the types of coatings, that silicon rubber coatings, which is also known as SRC coating. Silicon rubber coatings are also known as hydrophobic, which are used to prevent the moistures and pollutants from adhering to the insulator surface. So in water forms droplets and rolls off and carrying away contaminants, and it reduces the leakage currents and prevents flashovers. It also restores the self-cleaning properties to aged or contaminated insulators. So the main application method is the spray coating, brush coating, dip coating, or of this. But the advantages of using the silicon rubber coating is that it has very excellent hydrophobicity, like that is water repellent properties, and UV and weather resistant, and it also reduces the maintenance and cleaning frequency. But it requires the periodic reapplication after 5 to 10 years, and it can degrade under extreme pollution or chemical exposure. So next is room temperature vulcanizing RTV silicon coatings. RTV silicon coatings are similar to SRC, but it provides better adhesion and durability on insulators. So it forms a permanent hydrophobic layer on a ceramic, glass, or polymer insulators, and repels water and reduces the contamination which are induced to contamination induced flashovers. So as application methods are same, but advantages of this is it has very long lasting hydrophobic performance, and it provides a better adhesion to existing insulators. It is very resistant to salt, industrial pollutants, and UV radiations. But there are some disadvantage of using RTV silicon coating is that it has a very higher cost as compared to SRC, and it needs the careful surface preparation before applications. Okay, next is zinc based coatings, which is also known as metallic coatings. So zinc coatings such as zinc oxide coatings, it provides the anti-corrosion properties for metal components of insulators, and it acts as a sacrificial layer, and it prevents the corrosion on metal parts, and it improves the arc resistance in high voltage applications. And the main application method is hot dip galvanization, like dipping metal insulator parts in molten zinc, and then thermal spraying, and then we spray the molten zinc onto the surface, and plating, so depositing zinc on the metal surface using electrochemical process. The main advantage of this method is that it protects the metal hardware, that is insulator caps and pins, from corrosions, and it increases the mechanical strengths. But there are some disadvantages also, but it is not effective for glass or polymer insulators, that is zinc based coating is not effective for glass or polymer insulators, and it does not improve hydrophobicity like silicon coatings. Now, fourth is the ceramic and glass glazing. So, ceramic and glass insulators often have a glazed coating because to reduce the contamination and improve the durability. So, it forms a smooth glass like surface that repels dust and water, and it reduces the leakage currents by preventing the buildup of conductive pollutants. So application methods are high temperature firing in kilns to fuse the glaze onto the insulator surface, and main advantage of ceramic and glass glazing is that it provides the high mechanical strength and chemical resistance against acids, alkalis, and industrial pollutants. But it can crack under impact, and it is not as effective as silicon coatings in extreme pollution zones. So the next coating is fluoropolymer coatings. Fluoropolymer coatings, also known as Teflon based coatings, are non-stick and highly resistant to environmental pollutions, and it creates a low friction surface and preventing dust accumulation, and it is resistant to chemical UV rays and extreme temperatures. So but the main advantage of using is this is that high durability and chemical resistance. It also reduces the corrosion and contamination, but it's very expensive as compared to the silicon coatings and not being widely used in high voltage insulators. Okay, sixth is graphene based coatings. This is the emerging technologies and also known as the advanced nano coatings that improves the electrical insulation and thermal resistance, and it provides a conductive yet insulating barrier and improves some mechanical strength and self cleaning properties. The advantage of using this is that it provides the self-cleaning properties, which is similar to the silicone coating, and it is having the stronger and more durable coatings than the traditional coatings. But it is still in experimental stages and not being widely used in the commercial insulators. No, so there are some coating application techniques like I have discussed, I have taught spray coating that is best for large scale applications and it ensures a uniform thickness. Okay, next coating is brush coating. The brush coating is it is used for small insulators or localized repairs, and it is very less efficient for large surfaces. C is a dip coating in which insulators are dipped into a liquid coating solution as we discussed in zinc coating where insulators are discussed in zinc molten, and it provides a full surface coverage, and D is the thermal spraying. It is used for metallic coatings like zinc aluminum, and it involves the melting metal powder and spraying it onto the insulator parts. So these are the coating techniques by which coatings are done by different methods. Okay, so there are some factors, and based on that factor best coating types are selected by the manufacturer. Like in highly polluted areas they provide the RTV silicon coatings or fluoropolymer coatings, and in coastal and salty environments they use the hydrophobic silicon or graphene coatings, and industrial pollution and resistance zinc coatings and ceramic glazing can be done, and the long term durability the best coating type is fluoropolymer and graphene, and for ease of applications they apply the spray silicon brush on RTV. Okay, these are the uh, cleaning methods and coating techniques which are used for different type of insulators that I have discussed since first class, like the ceramic insulators, glass insulators, and polymers insulators. Now we discuss the hybrid insulators. So hybrid insulators are the mixture of polymer insulators and ceramic and glass insulators. Okay. So in the past, the main options for support insulators at air insulated HVAC substations were either solid core porcelain or composite insulators, which are up to only 245 kilovolt. But in addition, RTV coatings have at times been applied to solid core porcelain post insulators to improve the pollution performance. So new developments have been made when it comes to gas or foam filled hollow core composite insulators as well as large core diameters on solid core composite insulators. So nevertheless, the requirements for EHV line or UHVAC installation in terms of length, mechanical strength, permissible deflection, creepage distance, shed profile, pollution performance still present a challenge for all the existing insulator technologies. Okay, so the concept was to combine the service experience which are reported for solid core porcelain post with the proven pollution performance of insulators with silicon rubber housing. So the main challenge was to provide a reliable and cost-effective solution that combines the mechanical advantage of solid porcelain and electrical advantages of silicon housing for high pollution requirements. That's why we need hybrid insulators. So hybrid insulators are advanced electrical insulators that combine the benefits of traditional ceramic or glass insulators with modern polymer materials. It requires both the mechanical strength from the traditional and electrical strength from the polymer insulators. So they are widely used in high voltage transmission and distribution systems to improve the insulation performance, mechanical strength, and environmental resistance. So the basic need of hybrid insulators because of the traditional insulators such as porcelain, and glass have been used for decades in power systems due to their high mechanical strength and durability. But however, they are susceptible to contamination, moisture, and mechanical damage. So, on the other hand, polymer insulators made up of composite materials like silicon rubber, it offer better hydrophobicity and resistance to pollution, but have lower mechanical strength. So hybrid insulators integrate both materials to optimize their advantages. Now this figure shows shows the IEC 62896 chart, which explains the definition of the hybrid insulators, which takes the properties of the polymer insulators, which provides the electrical strength, and ceramic or glass insulators, which gives the mechanical strength. So this is the emerging insulators which are nowadays used for high voltage distribution networks. So this is the structure of the hybrid insulators, in which we can see the typical porcelain core, silicon shades, metal fittings. The core usually made up of fiber reinforced polymer, that is also known as FRP, for high tensile strength. This one. Okay, now second is silicon shades. Okay, this silicon rubber or polymeric materials that provide the hydrophobicity and pollution resistance. And next is end fittings. End fittings is made up of the metallic components for providing the mechanical support and connection to the power lines. And porcelain or glass housing. So it provides the additional mechanical strength and protection against the environmental factors. So here you can see the composition of porcelain core and silicon shades, which is made for the hybrid insulators. So many improvements in production technology and design optimization have been realized over the past several decades, and alternative solutions have been developed in terms of pollution resistance, size, and weight. And they have included porcelain solid core post insulators with the application of room temperature vulcanizing silicon rubber coatings, and solid core composite stations post insulators manufactured of fiber reinforced resin tubes with silicon rubber housing, and gas or foam filled hollow core composite station post insulators manufactured of fiber reinforced hollow tube with silicon rubber housings. So these are the improvements, and various developments for large core diameters on solid core composite supports insulators have been made, but they are limited by the rod production process. So in practice, the main which solid core composite insulators are applied mainly at the system voltages up to 220 kilovolt only. So since they cannot achieve the required cantilever strength and low deflection of the porcelain solid core post, so another approach has been hollow core composite post with gas or foam filling. So therefore, this technology could be applied for the post insulator as well as the hollow core and overhead line insulators. And such insulators were first developed in 1970s, which I have discussed in my first class for application on 25 kilovolt railway catenaries. But by definitions, these hybrids insulators made up of ceramic or glass core with a polymeric housing and equipped with one or more metal fitting rings. So the main advantages of hybrid insulators is that it improves the pollution resistance, like hydrophobic nature of silicon rubber prevents dust and pollutants from accumulating and accumulation, and second is high mechanical strength. So the combination of porcelain or glass with the polymer materials enhances the durability, and it also provides the better performance in harsh environments like extreme temperature conditions, UV radiation, and chemical exposure. And their superior resistance to contamination reduces the need for frequent cleaning. Now, by using this, cleaning frequency is also reduced for. Okay, so also there are some tests for which are performed on hybrid insulators like design test, electrical test, and mechanical test. So design test verify the suitability of the designs, materials, and methods of manufacturing like technology. So since there are no specific standards for hybrid insulators like IEC 61952 and IEC 62217 were used for hybrid insulators. The following tests were considered as relevant for the hybrid post design, like thermal cycle pre-stressing, water immersion pre-stressing, steep front impulse voltage test, dry power frequency voltage test, test on shed and housing materials, hardness test, accelerated weathering test, tracking and erosion test, flammability test, and test on core material, water diffusion test, porosity test. Okay. Second is mechanical type test. So ceramic core. Okay, go. The ceramic core of hybrid post bears the mechanical load transmitted to the core by the end fittings. So therefore, since there is no existing hybrid insulator, standard testing of the mechanical properties were performed in accordance with the IC 60168. And third is electrical type test. So the standard electric properties in accordance with the IEC 60168, and it is a natural aging and pollution performance test. So there are some applications of hybrid insulators like can be used in high voltage transmission lines, distribution networks, railway electrifications, substation and switchgears. Excuse me. Sorry. There are some applications of hybrid insulators like it is used in high voltage transmission lines, distribution networks, railway electrifications, substation and switchgears. So these are all about the hybrid insulators. Hybrid insulators are becoming increasingly popular in modern power systems due to their superior performance. Excuse me, okay. मेरी क्लास चल रही है ना मैं मारूंगी मेरी देखो तुमको कितना मारती हूँ मेरी क्लास चल रही है जाओ यहाँ से अब मत आना सॉरी So, hybrid insulators are becoming increasingly popular in modern power systems due to their superior performance and reliability as compared to traditional insulators. And they provide an effective solution for improving the efficiency and longevity of electrical infrastructures. So the conclusion in this presentation is that as we know that the maintenance of insulators is very crucial for ensuring the reliability and efficiency of power transmission distribution networks, and various cleaning methods including water jet cleaning, dry cleaning, chemical cleaning, ultrasonic techniques help removing contaminants, preventing flashovers, and enhancing the service life of insulators. However, frequent cleaning can be costly and time consuming, which has led to the adoption of advanced coating solutions. Coatings such as RTV silicon coatings, hydrophobic nano coatings, polymer materials, improve the pollution resistance, and reduce the maintenance frequency. And these can enhance the long-term performance. Additionally, we have learned the development of the hybrid insulators, which combine the mechanical strength of the ceramic or glass with the superior electrical and environmental resistance of polymer insulators, and has further revolutionized insulator technology. So, these hybrid designs offer enhanced durability, lower weight, and improve contamination resistance, making them ideal for modern power grids. And moving forward, a combination of strategic cleaning, protective coatings, and hybrid insulators can significantly optimize the power system reliability. And innovations such as self-healing coatings and smart condition monitorings will further enhance the insulator performance, ensuring a more resilient and sustainable power infrastructures. So, uh, I have covered all the topics of this subject, I think. Recent advances of transmission insulators. Okay, so this is the last day of this subject, in which we have learned the cleaning methods, coating methods, and hybrid insulators. And is there any need of doubt session? Then let me know. And now we discuss about the objective questions, some objective questions. Okay, based on this presentation, so that everything will be clear. And there will be a exam for this based on the this subject. So now we discuss the objective questions. First is which of the following cleaning methods is the most commonly used for removing dust and dirt from the surfaces? First is sandblasting, second is solvent cleaning, third is ultrasonic cleaning, fourth is manual wiping. You can unmute yourself and give me the answer, whatever you are thinking, right? Okay, what could be the answer? Sandblasting, solvent cleaning, ultrasonic cleaning, manual wiping. Anyone?
Ultrasonic cleaning, ma'am.
Anyone else? Rohan, Arjit. So basically, the most commonly method used for removing dust and dirt from surfaces is manual wiping. Okay, so the correct answer is D, manual wiping. Now the next question is which coating method is typically used for applying a thin uniform layer of paint or metallic coatings? First is spray coating, electroplating, dip coating, and powder coating.
Deep coating.
Dip coating. Anyone else? Okay, the correct answer
Spray
is
coating.
hmm?
Spray coating.
Okay. The correct answer is spray coating. Spray coating is typically used for applying a thin uniform layer of paint or metallic coatings. Okay. Correct option is A. Now the next question is in which cleaning method is high frequency sound waves used to clean delicate parts? Options are sandblasting, ultrasonic cleaning, solvent cleaning, abrasive cleaning.
ultrasonic,
Anyone else? What could be the answer? Cleaning method. Which cleaning method is high frequency sound waves used to clean delicate parts? Sandblasting, ultrasonic, solvent, abrasive. Priya?
Ultrasonic cleaning.
Okay. Rohan, are you there? Okay.
yes ma'am,
Okay, what could be the answer, Rohan? It is ultrasonic or anything else?
ultrasonic,
Okay, the correct option is B, that is ultrasonic, which provides the high frequency sound waves to clean the delicate parts. Okay, for this, which coating process uses heat to bond a powdered material onto a surface? Which coating process uses heat to bond a powdered material onto a surface? First is electroplating, powder coating, galvanization, and dip coating.
powder coating,
Powder coating. Anyone else? Okay, the correct option is B, that is powder coating. Powder coating process used to heat to bond a powdered material onto a surface to coat the surface. Next question is what is the main purpose of abrasive blasting in cleaning methods? First option is to remove grease and oils. Second is to remove paint or corrosion. Third is to clean with chemical agents. Fourth is to polish the surface. Main purpose of abrasive blasting. What could be the answer? Anyone?
मैम 5 का बी.
B, to remove paint or corrosion. Anyone else? Okay, the correct answer is to remove paint or corrosion. It is the main purpose of abrasive blasting in cleaning methods. Now the next question is which of the following cleaning methods uses a chemical solvent to dissolve contaminants from a surface? First is solvent cleaning, second is sand blasting, third is abrasive cleaning, fourth is steam cleaning.
solvent cleaning,
Okay, anyone else? Okay, the correct option is A, solvent cleaning. This is this cleaning methods uses a chemical solvent to dissolve contaminations from a surface, like I have discussed zinc coating. Zinc coating in which zinc solvent is made to deposit the insulator inside the molten zinc and clean the surface, okay, and coating and provides the coating. Now the seventh question is in which of the following coating techniques is an electric current passed through a solution to deposit a metallic coating on a surface? In which of the following coating techniques is an electric current passed through a solution to deposit a metallic coating on a surface? Options are electroplating, dip coating, spray coating, and vapor deposition.
रे इलेक्ट्रोपेटिंग.
Electroplating.
Anyone? Okay, so electroplating, in which electric current is passed through a solution and deposits a metal coating on a surface. Okay, eighth question is, which of the following is a disadvantage of using solvent cleaning methods? Options are high energy consumptions, environmental pollution, difficulty in cleaning small parts, and D option is limited to non-metallic surfaces. Which of the following is a disadvantage of using solvent cleaning methods?
Ma'am, what was the answer of 7?
Option A is correct. Electroplating is the correct answer. हो रही है अभी हम्म, मेरे कान में होते से दर्द कर रहा है अंदर What could be the answer of question number 8? Go. Disadvantage of using solvent cleaning methods. So the main disadvantage of using solvent cleaning method is environmental pollution. Okay, question number 9 is, which of the following coating is commonly used to provide a non-stick surface on a cookware? Options are ceramic coating, epoxy coating, Teflon coating, and zinc coating. What could be the answer, anyone?
Ceramic coating.
Ceramic coating? Anyone else?
A.
Ceramic coating? Which options you are saying? A? Who is saying A, ceramic coating?
Myself, ma'am.
Okay. And Arjit, you? Okay. See here. Fluoropolymer coatings such as Teflon based coatings are non-stick and highly resistant to environmental pollutants. Okay. The correct options would be what? C. Teflon coating. Okay. This coating is commonly used to provide a non-stick surface on cookware. Question number 10 is, which cleaning method is used to remove contamination from hard to reach places by submerging the part in a solution or solvent? Which cleaning method is used to remove contamination from hard to reach places by submerging the part in a solution or solvent? Options are ultrasonic cleaning, solvent cleaning, steam cleaning, and vapor cleaning. The correct option of question number 9 is C, Teflon coating. Okay, not ceramic coating. Now, what could be the correct answer of question number 10? Okay, the correct answer of question number 10 is solvent cleaning. This is the method which is used to remove the contamination by submerging the part in the solution. Okay, now next question is which of the following cleaning techniques is particularly effective for removing fine dust and particulates contaminants from the surface? Options are sandblasting, vacuum cleaning, abrasive cleaning, and steam cleaning. Anyone? Priya?
Vacuum cleaning.
Okay, anyone else? Rohan, Arjit, Dilkesh? Okay, the correct option is vacuum
Vacuum
cleaning.
cleaning.
Sorry,
Vacuum cleaning.
it's a vacuum cleaning is the right answer. That is B is the correct answer. Okay. Now, question number 12 is which coating method uses a liquid phase to apply a protective coating and is commonly used for automotive finishes? Options are powder coating, spray coating, electroplating, galvanization.
Spray coating.
Spray coating. Anyone else? What options you are thinking correct? Answer me. It's not your exam. It's just a test type. What could be the answer other than who told spray coating?
Ma'am, Rohan.
Okay. Anyone else? Priya?
Spray coating, ma'am.
Okay. Spray coating is right answer. Spray coating uses in a liquid phase to apply a protective coating and is commonly used for automotive finishes. Okay. Next question is in the process of galvanization, what material is primarily used to coat metal surfaces? Options are nickel, zinc, aluminium, gold.
Zinc.
Zinc. Okay, anyone else?
Zinc.
Okay, right answer. This option B, zinc is correct. Now the next question is which cleaning method utilizes high pressure water or steam to remove contaminants from surfaces? Options are sandblasting, vapor cleaning, high pressure cleaning, abrasive cleaning. Okay, high pressure cleaning method is used for utilizing the high pressure water as the name suggests. Okay, so it removes the contaminants from the surface by applying the high pressure. I have discussed earlier what Pascal 2750 kilopascals are used for cleaning the contaminants which are deposits on the surface of insulators. So next question is option C is correct. Okay, high pressure cleaning is used. Now next question is, which of the following method is used to apply a uniform coating of paint or liquid coatings by immersing the objects in the coating? I think this is done. Okay, answer me. What answer will be right? Spray coating, dip coating, electroplating, powder coating.
Dip coating.
Dip coating. Anyone else?
Spray coating.
Spray coating. Anyone else? Okay, the correct option is B, dip coating. Okay, in which is used to apply a uniform coating of paint or liquid coatings by immersing the object in the coating. It is dip coating. Okay. Now the next question is, which of the following is a disadvantage of using powder coating? Which of the following is a disadvantage of powder coating? Options are limited color options. B is difficulty in applying to complex geometries. C part is high energy consumption. D is prone to peeling and chipping. What is the disadvantage of using powder coating?
Difficulty in applying to complex geometries.
Okay, anyone else? Okay, the correct answer is B, that is difficulty in applying to complex geometries. This is the main disadvantage of using powder coating. So next question is, which coating method is commonly used for providing corrosion resistance to steel and iron surfaces? Which coating method is commonly used for providing corrosion resistance to steel and iron surfaces? Options are electroplating, galvanization, powder coating, ceramic coating. Which answer? Which option? Anyone?
B.
B. Galvanization.
Yes, ma'am.
Okay. Anyone else? Priya, Rohan, Arjit. Anyone?
Powder coating.
Sorry.
Powder coating.
Galvanization.
Okay. The correct option is galvanization. This coating method is commonly used for providing corrosion resistance to steel and iron surfaces. Okay, the last question. In which of the following cleaning methods is the surface heated and cleaned using steam to dissolve contaminants? Options are steam cleaning, solvent cleaning, vapor cleaning. D is sandblasting.
Steam cleaning.
Okay, anyone else? Which cleaning method is the surface heated and cleaned using steam.
A. Steam cleaning.
Yeah, steam cleaning is the correct option. So this was the last question. Now your all the topics have been done today, and all the best for your exam. Okay, thank you so much for joining me, and you can provide a feedback. Okay, thank you so much, everyone. You can leave now.
Thank you, ma'am.
Welcome.